Hello and welcome to another one of these ADD videos. Today we're going to be discussing polar graphing, the basics and the concept of. So what is polar graph? What is the coordinate system? A polar coordinate system is going to be linking radii of concentric circles to different theta values. And the coordinate system actually is r comma theta. Even though r depends on what theta, it is r comma theta. So, for instance, the point 1 comma pi over 4 would be right here, because in the theta of pi over 4 direction, we went out one circle radius. Okay, the point 2 pi over 3. 2 pi over 3 is a reference angle of 60 degrees in the second quadrant. Go back and review your trig if you need to. But you would go 2 up, and there's your point, because that's theta equals 2 pi over 3. Now let's do negative 3 comma 3 pi over 4. So that's 45 degrees in the second quadrant, but instead of going in the 3 pi over 4 direction, we have to go in the exact opposite direction because of the negative radius right there. You guys see that? Remember, it's negative 3. So because of that, we have to go in the exact opposite direction, which is in the 7 pi over 4 direction. And we go out 3 in that direction. 1, 2, 3. So this point right here is your negative 3 comma 3 pi over 4. Even though we went in the 7 pi over 4 direction, it's because of that negative. Okay. There will be problems in which you'll be asked to convert from rectangular to polar coordinates. These are the main equations that you will need for that process if you want to find x and y in terms of polar coordinates, or vice versa. Or you can use this one here, and if you want to know the angle, that's this equation. Be able to switch from rectangular to polar. There will be a video completely separate from this one addressing that issue. Trig identities are also important. You know, your good old Pythagorean sine squared theta plus cosine squared theta equals r, or equals 1. Sorry. You can solve these two equations for your sine and your cosine and plug them into here, and then you'll get a rectangular equation. Or you might, just be able to solve for x and y and then plug into the other, just like the parametric stuff we've done before. Okay? So what you could do for these is you could just go through all of these, and you could do x and theta table. Actually, let me do it the other way, because theta dictates what x is going to be. Alright? But that's going to be a really difficult process, because you're just going to be shooting in the dark, and you'd have to pick so many angles for you to actually get a clear-cut picture. Okay? So there are a bunch of basic formulas that we're about to go through that if you memorize them, your life will be so much easier when it comes to polar graphing and how to do them. But before we do that, we should discuss something called tangents at the pole. Tangents at the pole are equivalent to vertical or horizontal asymptotes in the rectangular system. They're kind of like the imaginary barriers of the polar coordinate system. So the tangents at the pole, you're literally forcing your r back to the pole or the origin. So they're the, if you will, the asymptotes of the polar system, driving r back to 0. And I'll explain that and clarify it. I just wanted to introduce the concept. That way when you see it later, you're not wondering what the heck I'm talking about. Alright? So let's start out basic, and then we'll build to more complex functions. First two we're going to do is the circles. if I have r equals a cosine theta, that's going to be a circle that looks like this on the x-axis, where a is this diameter of the circle. If it's negative, if a is less than 0, this is a greater than 0. If a is less than 0, it's in this direction. Oops, that's a rough looking circle, sorry. It's still going to be a. And that's if a is less than 0. Now, by the same logic, hopefully you can see that a equals sine theta would be in the y-axis, with this diameter being a. And then for less than 0, it would be going down. Okay, that's that. Now, if we have one of these two equations, it's a rose petal. And rose petals have this kind of shape. And what you'll do for these rose petals is you will find the tangents at the pole. Remember what we just discussed, the asymptotes of the polar coordinate system, and you do that by setting r equal to 0. Then after that, you're going to set it equal to r max and r min, and I'm going to go through a video for each of these except for probably the circles. I might jumble that in with one of the other ones. And then you're going to plot the petals, and the number of petals depends on what b is up here. This b value, if it's odd, and n is the number of petals, so n, if b is odd, n is equal to b. But if it's even, that b value, then you have to double it to get the number of petals. Okay? Again, this is just a conceptual video. Try to just see the big picture here. You're probably going to need to rewind and pause and kind of get an idea of what's going on, let the stuff sink in. Okay? Then there's a series of curves that are based off of these equations here, either that or that. And if we look at the ratio of a over b, excluding the plus or minuses, just the pure numbers a and b, then you can start getting general ideas of what to do. And for these, what you're going to do, the a over b lesson 1 is slightly different, but what you're going to do is you're going to actually do a table. You're going to pick the main axes as your theta values, and you're going to get the corresponding r. So you do 0, pi over 2, pi, 3 pi over 2. And then you find out what the r's are, plot the points. For a few of them, you'll do the tangents at the pole also. Alright. But the first one, a over b, is a limison with an inner loop. Looks something like this. And we will find that inner loop by using the tangents at the pole. And they'll also tell you how thick these humps are right there. Okay? If it's a over b equals 1, it's a cardioid. Not the best looking cardioid ever, but you get the idea. I guess I can make it a little prettier. And again, you're going to be doing the same table thing, tangents at the pole. And then here we're going to have a concave limison. So it's going to look something like that. And then here we're going to have a convex one. And it's going to, oops, roughly look something like that. Okay? And as you can see, these two right here will not have the tangents at the pole because they never touch the origin there. Okay? The last shape is a lemon skate. You're going to do this one kind of like the rose petal ones. As you can see, that it's just basically a rose petal looking structure. and I'll go through that again when it comes down to the rose petal example videos. Okay, so the main thing is you want to go back through these individual shapes. I recommend making some note cards for these basic things. If you look at these maybe 5 minutes a day for 3 or 4 days, you'll have them memorized, and there'll be that much less stress. It's a good idea to know how to graph well, because it's very difficult to do any of the area or arc length problems if you don't know how to do the polar graphing well. Okay, so I hope this has answered any questions that you might have. Practice, practice, practice. Thank you, and have a nice day.